All around us, right now, there's this invisible force pushing on everything. I mean, everything, including you. It's the reason your car tires don't just go flat, and it's what keeps a balloon all puffed up. So today, let's dive into the science behind this constant, powerful, invisible push, what we call gas pressure.
But seriously, just think about it for a second. What is really holding up a heavy car on just four little patches of rubber? Or what's going on inside a balloon that's fighting to keep its shape? It almost seems like magic, right? Well, it's not. It's pure physics, and the answer starts at a scale so small you can't even see it. To get to the bottom of this, we've got to shrink ourselves down. I mean, way, way down. We're about to enter a world filled with what you can almost think of as tiny, invisible bullets. And believe me, this is where all the action is. Okay, let's meet the main characters of our story, gas particles. The very air you're breathing right now, it's absolutely packed with them. Trillions upon trillions of these individual molecules, like nitrogen and oxygen. These little guys are the key to absolutely everything. Now, these particles, they don't sit still. Ever. Just imagine this totally chaotic scene. They are constantly moving, never stopping for a break, and they're zipping around at incredibly high speeds like microscopic rockets. But here's the kicker. All this motion is completely random. They're bouncing off each other, changing direction. It's like a universe of beautiful, controlled chaos. So how in the world does this storm of zipping random particles create a steady, powerful force? Well, the secret is in a single event, an event that's repeated trillions of times over. Let's zoom in even further and see what happens during just one of these collisions. Okay, so picture one single particle inside a tire. It's flying straight for the inner wall. Then, bam, it makes an impact. It immediately rebounds, bouncing off in a totally new direction. But this is the most important part. That tiny little impact, that change of direction, it actually exerts a microscopic outward push, just a tiny little tap on the wall of the tire. One collision, one tiny little bit of force. By itself, the push from one little particle is, well, it's basically nothing. You would never ever feel it. But see, this isn't a story about just one particle. It's about what happens when you get trillions of them working together. This is where all those tiny, insignificant taps combine to create something incredibly powerful.
And the numbers we're talking about here are they're staggering. This isn't a few hundred collisions or even a few million. Nope. On every single square inch of a balloon's inner surface, trillions of these impacts are happening every single second. It's a constant bombardment on a scale that's almost impossible to imagine. So here it is. This is where it all comes together. That single collision is just a tiny, completely unnoticeable tap. But when you have trillions of those taps bombarding a surface from every direction all at once, they just merge. You no longer feel the individual hits. Instead, what you get is a single, smooth, and incredibly powerful outward push. And this collective, constant push, this thing that comes from all those countless collisions, well, it has a name you already know. We call it pressure. So let's actually define what that means. To put it simply, pressure is the combined force from all of those particle collisions. But it's a little more specific than just the total force. It's really about how that force is spread out over a certain area. You see, pressure really has two key parts. First, you've got the force. That's the grand total of all the outward pushes from every collision combined. And second, you have the area, which is just the size of the surface that force is pushing against. So really, pressure is a measure of how concentrated that force is. And just like that, we're right back where we started. The mystery is solved. It's not some kind of magic holding up your car. It is the relentless, collective force of trillions upon trillions of air particles colliding with the inside of your tires every single second. That, right there, is the power of gas pressure. So I'll leave you with one final thought to chew on. The air all around us, the Earth's atmosphere, is also a gas, and it's full of those same chaotic particles. That means it's creating pressure too, pushing on you from all sides, right now. So the question is, how much force is the atmosphere actually putting on your body at this very moment? I gotta say, the answer might just surprise you. Thanks for joining me.